Welcome back, everyone, to the deep dive. Today, we're going to be tackling something pretty massive, and
Yeah.
that is how to decarbonize these really heavy industries. We're talking about steel, cement, chemicals.
Mhm.
I mean, these are the sectors that build our world, right?
Right.
You know, they make the materials that we use for everything.
Foundations
Foundations, yeah.
of our modern world.
Absolutely.
Yeah.
But here's the catch. They also spew out a crazy amount of CO2. Like, we're talking about 30% of global emissions.
That's a huge chunk.
It's a huge chunk.
Yeah.
And finding cleaner ways for these industries to operate is not a walk in the park, right?
Not at all.
Because their processes are so energy intensive.
Right.
You know, they require incredibly high temperatures,
Mhm.
huge amounts of energy. And that makes those simple solutions that we hear about, like, oh, just electrify everything.
Right.
They just don't quite cut it with current technology.
It's a bit of a
bit of a challenge.
a challenge.
So that's where our deep dive comes in today. We're going to be looking at green hydrogen as a potential solution,
Oh,
Can green hydrogen maybe be the answer to this really tough problem? And we've got some interesting analysis here
okay.
that digs into a few key questions. First, how feasible is this transition to green hydrogen, really?
Mhm.
Can it actually be done? Second, how do we get the costs down?
Yeah, that's a big one.
Because right now, it's expensive, right? And finally, what kind of partnerships do we need to make this whole thing work?
Yeah.
Because it's not going to happen in isolation.
Absolutely not.
Right. So, before we jump into the nitty-gritty,
Okay.
let's quickly clarify what we mean by green hydrogen because,
Yeah.
we hear hydrogen thrown around a lot.
Right. It's become a bit of a buzzword.
It is a buzzword. But green hydrogen is specific. It's hydrogen that's produced through a process called electrolysis. And I'm sure some of our listeners are familiar with this, but for those who aren't, basically you use electricity to split water.
Split those water molecules
Yes, into hydrogen and oxygen.
into their basic components.
And the key here is that the electricity comes from renewable sources.
Right.
So we're talking solar, wind, those clean energy sources.
It's the green part
That's the green part.
of green hydrogen.
Right, because if you're using fossil fuels to power that electrolysis,
Yeah.
then you're not really solving the problem.
You're just shifting the emissions around.
You're just shifting it around, yeah.
Yeah.
So green hydrogen, it's essentially taking clean energy
Well,
and making a clean fuel.
and that fuel can then be used
Yeah.
to decarbonize those hard-to-abate sectors.
Exactly, like steel, cement, chemicals.
Exactly.
It has the potential to replace those fossil fuels
Right.
that those industries are currently so reliant on.
The coal, the oil, the natural gas.
Right.
Yeah.
And that's where we see that potential for a really big impact. This analysis suggests that green hydrogen could become a direct substitute in a lot of these processes, leading to a huge drop in their emissions.
And it's important to remember the scale we're talking about. These aren't niche industries.
Right.
These are the fundamental building blocks of our infrastructure, our economy.
So any progress in decarbonizing them has a ripple effect across everything else.
Absolutely.
And, one of the things that really jumped out at me in this analysis was a statistic about the projected growth of the green hydrogen market.
Okay, yeah.
They say it's expected to skyrocket
Yeah.
from 0.33 million tons in 2024 to 1.57 million tons by 2029.
Wow.
That's a massive jump.
Yeah.
And that translates to a compound annual growth rate of over 36%.
That's incredible.
It's huge.
Yeah.
So what do you think is driving that kind of growth?
Well, I think it's a few things coming together. You've got governments around the world setting ambitious climate goals and putting policies in place to reach those goals.
So there's that policy push.
Right, there's that push.
Got it.
Then you have the technology itself improving electrolysis. The process for making green hydrogen is becoming more efficient and less expensive.
So the cost is coming down?
The costs are coming down. And then you have these heavy industries themselves
Okay.
starting to recognize that they need to find cleaner ways to operate.
Yeah.
They're seeing the writing on the wall.
They're seeing the writing on the wall, and they're also seeing that maybe this could be a way to, improve their image.
Absolutely.
Right.
Sustainability is becoming a key differentiator.
It's a big deal, yeah.
Yeah.
And it's not just projections either. This analysis also highlights a concrete example in China.
Okay.
They commissioned a 12 MW2 mWh green hydrogen-based energy storage site in Gansu province back in July of 2023.
So this is a real-world project.
It's a real project, yeah. And it's not just some small pilot program. It's a pretty significant deployment.
That's really encouraging to see.
What do you think this kind of project tells us?
Well, I think it shows that green hydrogen is moving beyond the theoretical.
Mm-hmm.
It's becoming a reality.
Yeah.
And the fact that they're using it for energy storage is really interesting
Okay, why is that so significant?
because it helps to address one of the big challenges with renewable energy,
Right.
which is intermittency.
Right. The sun doesn't always shine. The wind doesn't always blow.
Exactly.
Yeah.
So by storing energy as hydrogen,
Okay.
you can create a more stable and reliable power supply.
And that's something that these heavy industries need.
Absolutely, they need that consistent power.
Right. They can't just stop and start.
No, their processes often run continuously.
Exactly. Now, the analysis also touches on biofuels as another potential solution for decarbonization.
Hmm.
And it predicts that that market's going to grow, too, from 1.89 million barrels of oil equivalent per day in 2024 to 2.44 million by 2029.
Yeah, biofuels definitely have a role to play, especially in sectors like transportation,
Okay.
where you need those liquid fuels.
Right. But how does green hydrogen compare to biofuels when we're specifically talking about these heavy industries?
Well, I think green hydrogen has some key advantages.
Okay.
Remember, these industries need incredibly high temperatures, and in some cases, they even use fossil fuels as a feedstock.
Right, as part of the chemical process itself.
Exactly. Green hydrogen can directly replace those fossil fuels,
Okay.
both for combustion to generate heat,
Mm-hmm.
and as that feedstock in those chemical reactions,
So it's a more versatile solution.
it's a more direct replacement. Biofuels, while renewable,
Mm-hmm.
can face some challenges, like limited availability
No.
or competition with food crops for land.
And sometimes their energy density isn't as high.
Right. So I think for these energy-intensive industries,
Mm-hmm.
green hydrogen has the potential to be more scalable.
It's more tailored to their specific needs.
It's a better fit.
Yeah, it's a better fit. Okay, so we've established that there's a big emissions problem
Mm-hmm.
and that green hydrogen shows some real promise. But what does it actually take to make this transition happen?
Right. How do we get from here to there?
How do you actually start using green hydrogen in these industries?
Well, the analysis breaks down a few key steps.
Hmm.
First, you have to look at the technical feasibility. Can you actually integrate green hydrogen into existing plants?
So can you just swap out the old equipment for new hydrogen-compatible stuff?
Well, it's not always that simple.
Yeah.
You have to assess the existing infrastructure.
Okay.
Can you retrofit the furnaces? Can those reactors handle hydrogen?
Because it's a different fuel,
A
right?
different fuel. It behaves differently.
And safety is a big concern too, right?
Absolutely. Hydrogen is flammable.
So you need the right protocols in place.
You need the right infrastructure
The right infrastructure.
for storage,
Yeah.
for handling it safely. So what kind of adjustments might we be talking about here? Well, in some cases, you might be able to modify existing equipment,
Okay.
like changing the burners in a furnace or adjusting the fuel delivery systems.
Okay, so some things can be adapted.
Some things can be adapted,
Oh.
but in other cases, you might need entirely new technologies.
Like completely new furnaces designed for hydrogen.
Right, hydrogen-ready furnaces.
And then there's the whole infrastructure for transporting and storing hydrogen.
Yeah, that's a big one.
We're talking pipelines.
Pipelines, storage tanks.
Storage tanks, compression facilities.
It's a whole new system.
Yeah, it's a significant undertaking.
And, of course, there's the cost factor.
Mm-hmm.
I mean, we all know that green hydrogen is currently more expensive
Mm-hmm.
than traditional fuels.
Yeah, it's a big barrier to adoption.
So where do we see the potential for cost reductions?
The analysis highlights a few key areas. First, the technology for producing green hydrogen is getting better.
Mm-hmm.
Electrolyzers are becoming more efficient, and their manufacturing costs are coming down.
Okay, so the actual equipment is getting cheaper.
Right. Second, the cost of renewable electricity is dropping.
Right, because you need that electricity to power the electrolysis.
Exactly. And as solar and wind become cheaper, green hydrogen production becomes cheaper.
It's all connected.
It is all connected. And then there's the economies of scale.
Goes
As we produce more green hydrogen, the cost per unit goes down.
just like with any technology.
Exactly. The more you make, the cheaper it gets. Okay, that makes sense. But then there's the issue of getting the hydrogen to where it's needed.
Yeah, that's the transportation challenge.
Because you might produce it in a place with lots of sun or wind.
Right, but those places might be far from the steel mills or the cement plants.
So how do you solve that?
The analysis looks at a few options. Pipelines are often the most cost-effective for large volumes.
Okay.
But that requires building new pipelines or repurposing existing ones.
Right, like the ones that currently carry natural gas.
Exactly. For shorter distances, you can use trucks or ships
Okay.
to transport compressed or liquefied hydrogen,
But that can be more expensive.
and more energy intensive. So there's a lot of research going on
Okay.
to find more efficient and cost-effective ways to move hydrogen around
Because that's going to be key, right?
as a crucial piece of the puzzle.
And the analysis also stresses the importance of partnerships with renewable energy providers. Why are those collaborations so important?
Because you need a reliable and affordable supply of renewable electricity
Right, to power the electrolysis.
to make that green hydrogen.
And those heavy industries operate 24/7.
They can't afford interruptions.
They need that constant power supply. So partnering with renewable energy developers can help ensure that there's enough clean electricity.
Right, and it can help manage the intermittency issue
Yeah.
by coordinating production and storage.
It's like a symbiotic relationship.
It is, yeah. The heavy industries need the clean fuel. The renewable energy sector needs the demand.
And hydrogen acts as the bridge between them.
Exactly.
So to understand the foundation of these potential pathways, the analysis details its research methodology. How did they approach this complex topic?
Yeah, and I was impressed by how thorough they were. They used a combination of qualitative and quantitative methods.
Okay.
First, they looked at the current emission levels from these industries.
So they got a clear picture of the starting point.
Exactly, a baseline. They also analyzed the different green hydrogen production technologies,
Okay.
looking at their efficiency, cost, scalability.
So really digging into the nuts and bolts.
Yeah, they wanted to understand the technology landscape, and they didn't just stay in the lab.
Yeah.
They looked at real-world case studies.
So actual projects where green hydrogen is being used.
Right, to see what works, what doesn't work.
Learning from the pioneers, so to speak.
Exactly.
And to get a broader perspective, they conducted interviews with people from all sides of the issue.
Yeah, they talked to industry leaders in steel, cement, chemicals,
Okay.
renewable energy providers, technology developers, policymakers.
So they got insights from everyone involved. And they also did a cost-benefit analysis to assess the economic viability.
They looked at the upfront investments, the operating costs, and the long-term environmental benefits.
So trying to quantify those costs and benefits.
Exactly, because ultimately it has to make financial sense for these industries.
Right. Sustainability is great, but it can't bankrupt them.
No, it has to be a win-win. A win for the environment and a win for the bottom line.
So what did the analysis find? What are some of the key positive outcomes, or after effects, as they call them, that they anticipate if this transition to green hydrogen is successful?
Well, the biggest one is obviously the reduction in CO2 emissions.
Yeah.
That's the whole point.
That's the goal, but the analysis also points to other benefits.
Right, like a boost to their public image.
Okay.
Companies that embrace green hydrogen can position themselves as leaders in sustainability, which can attract customers, investors, top talent.
So there's a reputational benefit.
There is, yeah. And as environmental regulations get tougher
Yeah.
and carbon pricing becomes more common, that sustainability leadership can become a real competitive advantage.
It's not just good PR.
It's good business.
It's good business. And speaking of innovation, there's this really cool example.
Okay?
Siemens Energy and Siemens Gamesa are investing heavily in offshore wind turbines that can directly produce green hydrogen.
Wow.
They want to have a full-scale demonstration of this system by 2025 or 2026.
So they're essentially creating a self-contained clean energy system.
Yeah, it's pretty amazing.
It is. That's the kind of forward thinking we need.
So when do you think we might see green hydrogen become cost competitive with fossil fuels?
That's the million-dollar question. The analysis suggests it could happen within the next decade or so
Okay.
for certain applications and in certain regions. But it depends on a few things.
Like what?
Continued technological advancements,
Yeah?
supportive government policies, and the scaling up of production.
So we need to keep pushing on all those fronts.
We do. And once that economic tipping point is reached, I think we'll see a huge surge in adoption.
It'll become the obvious choice.
Right. The economics will make sense. And it won't just be limited to these heavy industries.
Okay.
Other sectors will start to see the potential as the infrastructure grows and the cost comes down.
So it could have a snowball effect?
It could, driving decarbonization across the whole economy.
It's a pretty exciting prospect.
It is.
And the analysis also delves into the experience of their specific client. Obviously, they don't name the client, but they talk about the benefits that this client saw from exploring the green hydrogen strategy.
Yeah, and it's a great example of how this can work in practice.
So what were some of the key takeaways from that client case study?
Well, first and foremost, they were able to project significant reductions in their carbon emissions.
Okay, that's the big one.
That's the environmental win. And that immediately improved their public image.
Right. It shows they're taking sustainability seriously.
They're walking the walk.
Yeah.
They also gained a potential competitive advantage.
Okay, how so?
By being an early adopter,
Mm.
they're positioning themselves as leaders in this space, which can attract investors who are looking for green opportunities.
Right, everyone's talking about ESG investing these days.
Exactly. And it could also open doors to new partnerships and collaborations.
So there's a strategic benefit as well.
There is, yeah. And maybe most importantly, the analysis found that exploring green hydrogen helped this client reduce their reliance on fossil fuels.
Okay, so it gives them more energy security.
Right. They're less exposed to price volatility and supply disruptions.
Because those are real risks in today's world.
They are.
Yeah.
And that's especially important for industries that rely heavily on energy.
Yeah, like these heavy industries we're talking.
Exactly. So it wasn't just about finding a cleaner fuel. It was about making their business more resilient for the future.
It's a smart move.
It is.
So, to sum it all up for you, the listener, this deep dive into green hydrogen has revealed that it's not just some pie-in-the-sky idea. It's a real and increasingly viable pathway to decarbonize these crucial industries.
And it has the potential to be a cornerstone of a sustainable future.
And the analysis highlights the growing technical feasibility, the anticipated cost reductions, and the critical role of partnerships.
It's not a silver bullet,
Right.
but it's a really promising solution.
And the research that underpins this analysis was really impressive. They examined emissions, technologies, real-world examples, stakeholder perspectives. They left no stone unturned.
And their cost-benefit analysis really underscores that the long-term advantages are significant.
Both for the environment and for the economy.
Exactly.
And I love that example of Siemens Energy and Siemens Gamesa. Working on those offshore wind-powered hydrogen production systems, it shows that innovation is happening.
That's what's so exciting about this field.
Yeah.
There's so much potential for breakthroughs.
Yeah, it feels like we're on the cusp of something big. And as we saw with their client case study, the benefits of embracing green hydrogen extend far beyond just reducing emissions.
It can improve a company's image, it can make them more competitive, it can even enhance their energy security.
So it's really a win-win-win.
It is. It's good for the planet, it's good for business, and it's good for the long-term stability of these industries.
So as you think about everything we've discussed today, consider the broader implications. If green hydrogen continues to become more cost competitive, what other sectors might it transform, beyond just steel, cement, and chemicals?
That's a great question for listeners to ponder. What other energy-intensive industries could benefit from this technology?
And what innovations in hydrogen production, storage, or transportation do you think will be the real game changers in the years to come? It's a rapidly evolving field, and it's one to watch closely.
I agree.
So thanks for joining us on this deep dive into the world of green hydrogen. It's been a fascinating conversation.
It has.
And we'll see you next time on The Deep Dive.